standard agreement for providing on-call electrical services to a wastewater plant is typically a service contract. This type of contract establishes a fixed price for a specified period, usually 1 year, and includes a guaranteed response time. The pricing for an on-call electrical contract or service contract can vary depending on several factors. Firstly, the size and complexity of the wastewater plant. Secondly, the location. And thirdly, the availability of qualified electricians in the area. However, as a general guideline, a monthly retainer fee of $500 to $1,000 per month can be expected. A call-out fee between $200 to $500 per call is another source of revenue. The value of having an on-call electrical contractor with a 2-hour response time for a wastewater plant is significant. It ensures that any electrical emergencies or malfunctions can be addressed promptly, minimizing downtime and potential damage to the plant's equipment and infrastructure. This prompt response can lead to reduced risk of plant shutdown, improved operational efficiency, increased safety for plant personnel, compliance with regulatory requirements, and enhanced reputation and public confidence. Several additional considerations should be kept in mind when drafting such an agreement. Firstly, the scope of services should be clearly defined, outlining the electrical services covered under the contract, including emergency repairs, troubleshooting, and scheduled maintenance. Secondly, a response time guarantee should be included, typically 2 hours or less. Thirdly, the availability of the electrical team should be stated as 24/7/365, including holidays and weekends. Fourthly, performance metrics to track response times and the resolution of issues should be established. Lastly, provide proof of adequate insurance and bonding to protect both the wastewater plant and the electrical business. Regarding electrical installations at wastewater treatment plants, several NEC articles are particularly relevant. Article 500 addresses hazardous locations, as wastewater treatment plants often have areas where flammable gases or vapors may be present. It's crucial to properly classify these locations and select equipment approved for the specific class, division, and group. Article 501 covers Class I locations, where flammable gases or vapors are present. Article 502 pertains to Class Roman II locations, where combustible dust is present. Article 503 addresses Class Roman III locations, where ignitable fibers or flyings are present. Article 505 covers zone classifications, an alternative method for classifying hazardous locations. Article 517 addresses healthcare facilities, which may be relevant if the wastewater treatment plant has associated medical facilities or laboratories. Article 547 addresses agricultural buildings, which may be applicable if the wastewater treatment plant handles agricultural waste. Article 600 covers electric signs and outline lighting, which may be used for signage or advertising purposes. Article 620 addresses elevators, dumbwaiters, escalators, moving walks, platform lifts, and stairway chairlifts, which may be present in some wastewater treatment plants. Article 625 covers electric vehicle charging systems, which may be installed to charge electric vehicles used at the plant. Article 640 addresses audio signal processing, amplification, and reproduction equipment, which may be used for communication or entertainment purposes. Article 645 covers information technology equipment, which may be used for control and monitoring systems. Article 660 addresses X-ray equipment, which may be used for inspection or analysis purposes. Article 665 covers induction and electric heating equipment, which may be used for industrial processes. Article 668 addresses electrolytic cells, which may be used for certain wastewater treatment processes. Article 670 covers industrial machinery, which may be used for various operations at the plant. Article 675 addresses electrically driven or controlled irrigation machines, which may be relevant if the wastewater treatment plant irrigates land with treated wastewater. Article 680 covers swimming pools, fountains, and similar installations, which may be present for recreational or aesthetic purposes. Article 682 addresses natural and artificially made bodies of water, which may be relevant if the wastewater treatment plant discharges treated wastewater into a water body. Article 690 addresses solar photovoltaic systems, which may be installed to generate electricity for the plant. Article 692 covers fuel cell systems, which may be installed to generate electricity for the plant. Article 694 addresses small wind electric systems, which may be installed to generate electricity for the plant. Article 695 covers fire pumps, which are essential for fire protection at the plant. Article 700 addresses emergency systems, which provide power to essential equipment during power outages. Article 701 covers legally required standby systems, which provide power to equipment required by law to operate during power outages. Article 702 addresses optional standby systems, which provide power to non-essential equipment during power outages. Article 705 addresses interconnected electric power production sources, which may be present if the wastewater treatment plant has multiple sources of power. Article 725 addresses Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits, which are used for various control and automation systems. Article 760 covers fire alarm systems, which are essential for fire protection at the plant. Article 770 addresses optical fiber cables and raceways, which may be used for communication or data transmission. Article 800 covers communication circuits, which are used for telephone, internet, and other communication services. Article 810 addresses radio and television equipment, which may be used for communication or entertainment purposes. Article 820 covers community antenna television and radio distribution systems, which may be used to distribute television and radio signals. Article 830 addresses network-powered broadband communications systems, which may be used for high-speed internet access. When working in these areas, it's also important to consider the requirements for intrinsically safe circuits and equipment, as outlined in Article 504. These circuits are designed to limit the energy available to a level that is below that required to ignite a flammable atmosphere. Understanding these NEC articles is essential for ensuring the safety and reliability of electrical installations at wastewater treatment plants. In addition to hazardous locations, wastewater treatment plants also present other unique electrical challenges. Firstly, corrosion is a major concern due to the presence of moisture, chemicals, and gases. Electrical equipment must be selected and installed to withstand these corrosive environments. This may involve using corrosion-resistant materials such as stainless steel or fiberglass and applying protective coatings. Secondly, grounding and bonding are critical for preventing electrical shock and ensuring the proper operation of equipment. The grounding system must be designed to effectively dissipate fault currents and provide a low-impedance path to ground. All metal equipment and enclosures must be properly bonded together to create an equipotential plane. Thirdly, surge protection is essential for protecting sensitive electronic equipment from voltage transients caused by lightning or switching operations. Surge protective devices should be installed at the service entrance and the downstream panels to provide comprehensive protection. Fourthly, motor control is a key aspect of wastewater treatment plant electrical systems. Motors are used to drive pumps, blowers, and other equipment. Motor control centers should be designed to provide reliable and efficient control of these motors. Variable frequency drives can be used to adjust the speed of motors, which can save energy and improve process control. Fifthly, lighting is important for providing adequate illumination for plant personnel to perform their tasks safely and effectively. Lighting fixtures should be selected to provide the appropriate level of illumination for the task being performed. Energy-efficient lighting technologies, such as light-emitting diodes, can be used to reduce energy consumption. Sixthly, instrumentation and control systems are used to monitor and control the various processes at the wastewater treatment plant. These systems rely on a variety of sensors, transmitters, and controllers. The electrical systems for these devices must be designed to provide reliable power and communication. Seventhly, standby power systems are essential for ensuring that critical equipment can continue to operate during power outages. Standby generators or uninterruptible power supplies can be used to provide backup power. The standby power system must be designed to meet the specific needs of the wastewater treatment plant. Eighthly, safety is paramount when working with electrical systems at wastewater treatment plants. All electrical work must be performed by qualified personnel who are trained in safe work practices. Lockout/tagout procedures must be followed to prevent accidental energization of equipment. Personal protective equipment, such as rubber gloves and safety glasses, must be worn when working with electrical equipment. Ninthly, compliance with codes and standards is essential for ensuring the safety and reliability of electrical installations at wastewater treatment plants. The NEC provides comprehensive requirements for electrical installations. Local codes and standards may also apply. It is important to be familiar with all applicable codes and standards and to ensure that all electrical work is performed in accordance with these requirements. Lastly, documentation is crucial for maintaining and troubleshooting electrical systems at wastewater treatment plants. Accurate and up-to-date drawings, schematics, and equipment manuals should be maintained. A comprehensive maintenance program should be implemented to ensure that electrical equipment is properly maintained and inspected. Thorough documentation can help to identify and resolve problems quickly and efficiently. In addition to the technical aspects of electrical work at wastewater treatment plants, it is also important to consider the business aspects. Firstly, communication is essential for building strong relationships with wastewater treatment plant personnel. Regular communication can help to identify potential problems and ensure that electrical needs are being met. Secondly, responsiveness is critical for providing timely and effective service. Wastewater treatment plants rely on their electrical systems to operate properly. Quick response times can minimize downtime and prevent costly damage. Thirdly, professionalism is important for building trust and confidence. Electrical contractors should always conduct themselves in a professional manner and provide high-quality service. Fourthly, pricing should be competitive and transparent. Wastewater treatment plants need to be able to budget for electrical services. Clear and accurate pricing can help to build trust and ensure that expectations are being met. Fifthly, safety should always be a top priority. Electrical contractors should have a strong safety program and ensure that all work is performed in accordance with safe work practices. Lastly, continuing education is essential for staying up to date on the latest electrical technologies and codes. Electrical contractors should invest in continuing education to ensure that they are providing the best possible service. By considering both the technical and business aspects of electrical work at wastewater treatment plants, electrical contractors can provide valuable services and build long-term relationships with their clients. Remember to always prioritize safety, compliance, and professionalism in all aspects of your work.